Welcome back to my new video. In today's video we are going to solve a geek problem which name is missing number in an array. So let's understand this problem. We have given an array of size n minus 1 such that it only contains distinct integers. Means the array which is given to us, it will only contain unique values in the range of 1 to n. We have to return the missing element. Let's see first example. We have given n is 5 and the array is 1, 2, 3 and 5. So we have to return the missing element, missing number. So here the missing number is 4 because the number should be 1, 2, 3, 4 and 5. So the 4 is missing. Remember, the array's value would be n natural numbers. N can be anything in the range of 10 to the power 6 and the element will also go to up to 10 to the power 6. We have to solve this problem in the time complexity in big of n, and the space complexity should be also big of 1. So let's take another example, like if the value of n is 2, so the element should be 1 comma 2. There is only 1, so the missing value is 2. So we have to return the missing value which is 2. So let's see how are we going to solve this problem. So let's talk about approach. Think like we have given the array of n natural numbers, so there would be a chance there would be always one value missing and n unique values. The array will always contain n unique values. There would be always one missing values, I mean value. So let's see how are we going to find this missing value. See, if we know the sum of n natural numbers, like sum of n natural numbers, as we know the formula mathematically, the sum of n natural numbers, which is n into n plus 1 by 2. The sum of n natural numbers is n into n plus 1 by 2. So if we know the sum of n natural numbers, so we can easily find the missing values, right? Like if we do 1 plus 2, this is the sum of this. 1 plus 2 plus 3 plus 5, it would be what? 5 and 3 8, 8 plus 2 10, 10 plus 1 it would be 11, right? And the sum of n natural numbers, here n is 5, so the sum of n natural number, if we put n equal to 5, so what will we get? We will get so it would be 5 into 5 plus 1, which is 6 by 2. It would be 2 3s are 3 5s are 15. It would be 15. So the sum of the whole element is 11 and sum of n 5 natural number, which is 15. If we subtract the sum of these numbers, we will get what? The missing number, which is 4 in this case, right? So the first approach is like this. If we know the sum of n natural numbers and we minus the sum of the total array, then we will get the missing number, as you can see. And one more efficient way to do this is we know the sum of a natural number is this, which is 15, and and as we know the sum of a natural number is 15. So for first element we will start a loop. We will decrement that first the value of first number, which is 1. 15 minus 1 is what? 14. So here is 14, and we will iterate through each element. So we'll decrement this 2 also. So 14 minus 2 is 12, and then this 3, decrement this value. 12 minus 3 is what? 9. Okay, and the last value is 5. 9 minus 5 is what? Which is 4. So we have found the missing value. So this was our sum, and we have to decrement each value from the array. And if we decrement each value from the array, so we'll found the missing value. So let's try to write the code for this algorithm. So in this approach, we first have to calculate sum of n natural numbers. So it is n into n plus 1 by 2. Correct, right? And then we just have to decrement each element from the sum, and after the end of the loop we will get our missing value. So we just have to traverse through the array. We have to decrement each element of the array, and after the end, in the end we will have our answer in sum. Like in this case, the sum of n 5 natural number is 15. So we'll decrease this 15 minus 1, 2, 3 and 5. So 15 minus 11 would be 4. So our missing value is 4. Let's try to submit the code. Semicolon expected. Let's try to again run the code. Hence there are no errors. So let's submit the code. So we have passed all of the test cases. We have solved this problem in big of n time complexity and big of 1 means constant space complexity. That was an easy problem, but finding the solution sometime thinking out of the box is hard, which makes the problem hard. So always try to think out of the box to solve this type of problems. Thanks for watching.